Morning, y'all. I am gonna be going through some studying here. As I said before, I just want to start practicing my algorithms with Java, and I'm just gonna do it publicly. I have no qualms with that. So I'm just gonna practice in public, and if other people benefit from it, great. And if it's just me, that's also cool. But it's sort of a motivation for me to keep going. Not that I wasn't already doing this stuff; I am already doing it. So, um, before I go, like before we were on this other website that I've been using, I'm gonna keep doing that website, but I want some basic foundational stuff that I don't think I have yet on linked lists. So with Java, I know linked lists sort of from a Python perspective, but doing it in Java is interesting because it's lower level into the code base. So I'm going to practice this stuff and try to learn it, and hopefully you get something from this too. So we'll do that for a little bit today, and I'll get back to RP later. All right. Let's get going. So, in this book I'm reading, Cracking the Coding Interview, right? I'm starting to build out this node class, all new to me. All right, so no, I'm literally just verbatim going to copy this out. So you have node, so you're calling some object node, and hold on, just need to make sure I have all of my information that I need. Oh, okay. So, yeah, if you're looking for RP, by the way, that will happen later in the day. I switch between doing the things I'm interested in casually as like a hobby, and then, the things I'm interested in as I like to do for studying and for work and stuff like that. So this channel is going to be multiple things. That's fine with me. All right, so you start with this class node, and you're assigning an object the type node called next, and next equals null. All right, so far this makes sense. We'll probably add a bunch of comments, etc. throughout. It's this way in Java, blah. So we'll annotate this stuff. We can go as slow as we want. This is for no one but ourselves, right? So let's just do this the way that we can. Because if you get a mastery of the fundamentals, the thinking goes, then as it becomes more complicated, you don't get slowed down as much. All right, then you get an object called int data, and you're just saying, hey, this int object exists, and it's for data. All right, cool enough. And you're going to say, I'm just copying this code. This is not from my heart, or from the head. Okay, we'll walk through this. First, I'll just write it out. Data equals D. All right, so what just happened here? There is a public class, this, and then a public method called node. And you give node or constructor, I guess. You give this constructor this int object called D, whatever D is. D is some integer. And you assign D to the data type, data, so that node will have access to it later. Okay, great. And we put them in brackets because that's how things work. You arguments here, objects and actions in here. All right, good enough. Anything else? Yes. Void, meaning something is not returned. Append to tail. All right. Int D node end equals new node D. All right. Let's walk through what that is. So there's some object in this method. Remember, I am new to Java, so I'm working through things if I use the wrong words or whatever. That's the whole point of this, right? That's the whole conceit. That's all right. We're assigning a node object, right? This right here, called end, and we're creating a new node That's this constructor right here. So we're constructing a new node from an integer d. This is going to be type integer. And d is going to be assigned to data. So data will then exist. And next will be null. Okay, so this so far this makes sense. This is nothing crazy. Node n equals this. We'll talk about this in a second. I'm not an expert, but I know that much. N dot next equals, when it does not equal null, what are we doing? N equals n dot next. All right, sure. Then what? And then that's it for that. And let's just end this with this right here. Dot next equals end. All right. So that's the entire piece of code. Let's walk through what this is. So we get this method. So this is the constructor, and this is a method. And the method says for this class, append to tail, which it's a major hint of what it's doing, right? We're gonna get some object integer. We're gonna construct the class through the constructor with the integer d. So this could be 1, and 1 is going to equal the node type end, and then we're gonna say n is this. That's gonna be that's an interesting one. So if you know Python, so like a quick thing about Python. I don't know if you know Python. For me, this is where I relate. And by the way, learning is, I am not an expert, but the theory I'm going to have in this channel, and theory that I really subscribe to in my life, is like the best way to retain knowledge, besides repetition, is connecting new knowledge analogously to something you already know. By making these connections, we're also making connections up here, right? It doesn't even have to be entirely true. It's just like a mnemonic. It's just trying to relate to what you already know, because knowledge is relations. We can't help that. So we're gonna relate knowledge to what we have, and if you don't know this other knowledge, that's okay. We'll keep going, relate it to something you know. But in Python, the syntax won't be right. If you make a class and you call the class like my class, my class, and you construct it, and then you init. You got like def init, because I'm much more comfortable in Python. And you've got self, right? And then self dot something like foo. We're making up the name is, let's say n is an integer, so we can say int, or n is an integer. Then you would say is n. All right, and then you would later, like in some other thing, some action, we'll just call it self dot action. You would say self dot foo, and you can call foo because it was created right here, and foo is going to equal n. This, it seems to me, is equivalent in conceptual. It's not equivalent. It is analogous to self in Python classes. That is, self is this is self-referential. This is saying this. This is saying whatever the node object is, use that object and call that object n. We could also call this self, right? And then it would be self.next, right? So in my understanding of Java, and I am not an expert, this is self in pandas or in Python. And that's helpful because I learned Python before I learned Java. If you know Java and you don't know Python, reverse kind of goes. These will not be one-to-one, and we're not trying to get one-to-one knowledge. We're just trying to do this. All right, so we go through, we're saying reference the object itself and call it n, and then saying n.next. Well, n.next would be that one right there, right? And so we're saying if n.next does not equal null, then go through and the next object is going to be n. So you're saying this new int object, just call it n. All right. And then you'll say n.next equals end. And end is this new node object. Gotcha. All right. So let's comment this out. I may be wrong, but this is sort of my understanding of how this is going. We've got some class. So let's just, let's really go to the basics here. Initialize some class node. Assign an object within node, the type node, inside an object next within node, the type node. And assign an object next within node, the type node, and value null. Okay, good stuff. Next, we're just gonna do this for a little bit until we get more fluent in Java. Data. Okay, so here the thing about Java and many other classes is you can just assign a type and not use an object. You just be like, this type exists. We will use it later. Don't worry about it. Right now, you just know it's an int. So you say, create an object name data with type int. Okay. And we'll talk about like the meaning of why we're even doing this in a second. I probably should always start with that because it's more interesting to me anyway. Constructor, that is, so we'll say create a constructor. Create a constructor that is a means through which to create the class with, and here if it gets too long, we can make this a comment. We're not gonna do this every time because we know what this is, but for now we're just gonna do that. If you need a multi-line comment in Java, you can do this thing. Bam, bam. Great. Create a constructor that is a means through which to create the class with object, how about this? As an integer object D. Okay? As an integer, how about this? Passing into it an integer object D. That's much better. Next. So that's what's going on here. Assign D to the self.data object data. Think of Python. I'm relating to knowledge that I know that may not be helpful for you, but it's helpful for me. Okay, and then here's a method. I don't know if they call it methods. I think they do. Create a method in Java such that if you call node.append to tail, I think this is how it's going to work. Append to tail something. Let's make this multi-line. Such that if you call them what will happen? To tail, you will be able to add to your linked list at the end. All right, how does that work? So you say first pass an integer D into the method. Create a new node object because a linked list is an array. We can call it an array. It's not a real array, but array of nodes. So we're saying like we need to create a node for each object, in this case an integer. The integer is the node. So we have to, if it's a linked list is, and this is a great opportunity. All right, so I'll stop here. What are we doing, man? Why are we even doing this? Right? A linked list is actually an interesting concept algorithmically and for our lives, right? A linked list is a dynamic array. What is an array? I am not an expert. By the way, I am completely self-taught in all of computer science. I have found success in this, but it's an interest. As I understand it, a linked list is a dynamic array, right? In your computers, you have, let's say, a bunch of objects. The objects could be, let's just put it in the list: 1, 2, 3, 4, 5, 6. Classically, what you could do is just call an array object as array equals this thing. Okay, and so the array is 1, 2, 3, 4, 5, 6, 6 objects long. And you'd say, your computer would say, okay, static memory, allocate. Oop, I hear cutting outside. I got a construction. I got to close the window. Right. Allocate this much, 6, let's just call it bits. It doesn't matter. 6 bits of space to that array. Great. And then you say, oh, but I want to add to my array. So you say array, and then like making it up, dot, append to tail, some other object. You want to get 7, right? Error occurs. Why? Static array was used. Your computer said, this is 6 bits long, and this is going to stay 6 bits long because it's a static array. That's what it is. Like I don't have any more space for that object because you gave me that type. It only knows static type. It can't infer for you that actually what you wanted was an array that can be n length long, right? When you code something up, the computer is going to do exactly what you say it does, given axiomatically that everything else in your computer is the way that it's supposed to be. There might be like a bit flip or something, and those are edge cases that no one's going to be able to, very few people can anticipate, right? But in this situation, what we have here is we said the array is 6 bits long. It will be 6 bits long. The computer was told that it's going to be that. If we create something called a linked list or a dynamic array, that's going to be different. Now imagine, and we'll call this dynamic array equals the same thing, 1, 2, 3, 4, 5, 6. And now the type here, let's say we'll call this was a type array, making it up, and this is called we'll call this node, right? Doesn't matter, but like imagine this was dynamic array. Dynamic array is dynamic memory. So allocate 6 bits as before of space to dynamic array. But the underlying code that represents the array is different. So now we say, dynamic array dot append to tail 7. Now what would happen is, in this made-up instance, I'm oversimplifying, since it's dynamic memory, the computer says, the type for this array was dynamic. I allocated 6 bits of space, but you actually want to put something else in there. That's okay, because the type of object that you used is programmed in such a way that we can do that. So we can say, bam, put something on the end. Now, why would you want one versus the other? Well, there are benefits to both. Here, you're not let's say you wanted to ensure that this is this amount of memory, that you could control the amount of memory, that there's no ballooning of memory, and that all the objects stay as they were, right? Then maybe you want to use a static memory object. But if you want a dynamic array because you want to mess with memory and stuff like that, then that's where you're going to end up using something like a node. So this comes into play in a lot of different places, but that's my understanding. I am no expert, but that's my understanding of things. Okay. So we create a new node object because of length is an array of nodes. That's where I got it on that tangent. And then we're saying, let's reference that array. So this, we're referencing this. And since this was already created, this is a new node. See, new, right? This is not referencing this new node. This is referencing the constructor node, right? Because node already is an object. The list exists, right? So in that case, what we have here is we're referencing the original node. Okay, so far so good. So then what we could do is say, okay, so reference the initial node that was created as n self. Okay, now we're saying while, that is for every value, or how about this? While this condition exists, while n.next does not equal null, while this condition exists, do something, right? This is the something, this is the condition. Fair enough. All right, what are we saying? While n.next, stop there. Where's n.next? n.next is up here. It's created when the constructor class is created. These are the types that it is given inherently, and this is the constructor class. So it's saying when n.next does not equal null. Okay, so this is n.next, right? Because if we implicitly, n is this. So this is this dot next, right? Oops. Okay. So there's a question though. Is n.next, like initially n.next is null. So how does this even happen? Like we start with n.next is null. I'm actually working through this in my mind. Let's see what happens here. Well, that's what this is. Okay, now I get it. In the case of the first append to tail, a linked, how about this? A node object will have n.next equals null. I'm going to write a little paragraph for myself. I don't care. There's no going wrong here. There's nothing. We are allowed to be as reckless and pedantic as we need to be until we understand what we want. This is our code, right? This isn't a class. We'll do what we want. Okay. In the first append to tail, a node object will have n.next equals null. Cool. In that case, that means that this will stop right away, right? So the first node object that we create, where we want to append to tail, we've created an object, a linked list. It's going to be like an array like this. It's going to be 1. Let's just use that example. n.next is already null since it's 1. So if we wanted to do, and we'll call this like foo. Foo equals this node object. It's a node. Node, and this is going to be, I don't know, node.node? Is that how I do it? No, I think this is going to be node like this. That's right. Right, so node is going to be this thing. Then what's going to happen is it's going to be foo.next is going to be equal to null because there is nothing else in the linked list. Then what will happen is n.next, when we want to append to tail, I'm jumping ahead, we'll say, okay, if this is true, let me put this as a comment because this isn't code we want. The first foo.next equals null. We can actually put that here because this is cool. Like, this can be as long as we want it to be. We don't care. So, ooh, I'm putting it in the wrong place. Here. So the first case, it's going to be like this. The first foo.next equals null. So we go straight to n.next n equals n.next. Oh no, I was right the first time. n.next equals end. I apologize for going back and forth there. So what we're saying here is we go straight to n.next equals end. That means in that case, what's happening is foo.append to tail, because that's the function we're in. So first we've created foo node, append to tail. Let's have a new number, I'll call it 2. What's going to happen is we go straight to n.next equals end. Now, foo is going to be equal to 1, we'll make this a list, 1 and 2, because n.next equals null, or n.next equals end, and end was assigned this node object, and this node object is the same thing as 1. So we're putting 2 numbers together, and that's how we're starting to dynamically add to the list. But let's do one more thing. What happens now if we tried to do foo.append to tail 3? Or it could be any number, but we're going to do 3, right? So we do this. Well, now we're going to say while n.next does not equal null, the first dot next equals 2. So we say change constructor to the 2 node, right? That's what this is. This is going to be a node because n is node right here. We gave it node type. So now it's 2 node, and then we do it again. 2 dot next equals, or it's really node. Let's do it like this so it'll make more sense. Node 2 dot next equals is equivalent to null, because nothing is, ooh, I don't know what just happened. Because where were we? After 2, node dot next is null. There's nothing there, right? So now we break the loop and we've appended node. Now it's gonna be foo equals 1, 2, 3. And that's what this is. Okay, that's cool. I'm glad I walked through that. I didn't know. I've never done this in my life. So that is useful. Let me practice one thing that I'm not good at. Because again, I'm new to Java. I'm gonna go to my notes quickly. I want to run this. Home. Also, I'm new to Windows because I'm whoa, not that, friends. This PC, users, me, documents. Where are friends? Or is it in Linux? No. I'm running Linux on the backend because I'm used to Linux and I'm used to personal. Goodness gracious. Where is this information? Open in, can I reveal in Java product? let's go to the terminal. I don't know where this file is in my file system. Go here, ls. Let's see, ls this. Where are we? Yes, but where is present working directory? Home.bjl, code. Yeah, I want to find this in my. Woof. How do I search in Windows, bro? Bruh. I am many things. I am not proficient at Windows. Favorite code. I'm looking. Home. I feel like this is a different file system. Well, that's interesting. Okay. I don't know why that is, but I have like 2 different file systems. I'm going to accept this and move on with my life. So let's what I wanted to do is just check out some code. So, can I run I think I can. So, this is void right here and we've done all of our notes. Now, within this class, let's do public static void main. And let's try to run this thing. String this thing args, isn't it? Yeah. And then oh, there's no comma there. Apologies. Okay. So this is saying like let's go into this code, this this node code, and let's practice running this node because I don't know, I just want to like see what happens. So the way we'll do this is first let's create a node. So let's call this node 1 equals node. Can I do this? No, how about this? Foo equals node dot. Oh, it's gonna be this, isn't it? Yeah, that's it. All right. Okay, you don't like this. Why do you not like this? Method node is undefined for object type node. I think I'm missing something, friends. New node? Foo? Yes, we did it. We're winners. We're coders. We are hacking the mainframe. Okay, that makes sense. So we have to assign the object type foo node, right? It's a new node, so we want to do that. It's telling me this is the object type, which is digit, integer. Okay. Then let's look at our results. So we're going to take system dot out dot print line, and then let's print foo. Okay. Let's just run this and see what we're at. Now, running the debugger in any IDE, we're in an IDE right now. What is an IDE? An interactive development environment, is really important. Getting comfortable with that because we can do some interesting things in it. For example, I want to pause after I've created this. And in fact, I want to pause going through this part right here. So let's do it. So I'm going to run my interactive development environment in the debugger mode. And we just stopped right there. So now what happens is I can pause the program before it keeps going. So we can break down what's happening. So we have some arg here, some Java code, fine. We have to stop because I did something wrong. What did I do wrong? Everyone, Java needs to be compiled. It is not like a Python file where you can just be like, go Python, you gotta compile it. Friends don't let friends run non-compiled Java code. Compile the code. Do it. Now we have node.class, right? So node.class exists. This didn't exist before. Now it does. So now compile the code and then run it. Aha. Okay, so d.1 exists and run it again. Now foo exists and foo data 1 exists and next equals null. Oh, man, I'm happy I'm doing this. This is really helpful for me as a person. So, what do we expect system out print line to be, right? We're printing out something. What is it going to look like? I don't know. Let's print it. It printed out this thing right here. I'm pretty sure that's just like the object's name, but we're in a good place. This is good. Like this is the hash of the object, I think. Let's make this a little bit more refined. So foo.data. If we run that, what's going to happen? First, compile, friends, compile code. Then, what do we think is going to happen? If we run java.solution, oh, that's not what I want. Java.node.java. I have no idea. Maybe I'll run the debugger. Maybe I'm just doing something wrong. We run it. What do we get? Oh, there we go. Perfect. We get out 1. And that's what we expected because data should be 1. It's right up here. We assign data as D. So data should be 1. And we had access to it, and we're good. All right. Let's become more complicated here. Let's do... So this is going to be just... try creating an object. Yay. Now, next. Try creating a list, a linked list of objects. Well, we can do that. Foo is already created. So let's do foo dot append to tail, and let's put 2 at the end of the tail. And then let's do system here, and let's do foo dot, what do we want? What is this? What do we want to print here? Ah, I know. Let's breakpoint here. Then, how are we going to print out the linked list? Well, the thing is, you can't print out the linked list because we haven't done that here. So, let's create a function in our node to do that. Okay, how? Well, actually, we're not going to do that yet. First, we're going to create a function outside the node. Let's create a for loop. For some condition, we'll talk about the condition in a second, do a thing. Okay, what is the condition? Now, I forget for loops in Java because I am a pleb. But I will find them. I will find my notes on for loops in Java. Again, I am literally new. Ah, that's right. This is how I do it. I remember in Python, but I'm a bad boy and I just went straight to Python. Okay, let's call an integer int. And we're gonna call it 0. And then we're gonna say we have to call it I for 0. Let's say while I is less than the length of the node. In this case, we know that the length of the node is 2 for our practice problem. Iterate I plus plus, which means iterate, add 1 to I every time you iterate through the for loop. Started at 0 because we start at 0 counting. Go up till we do not equal 2 because you minus 1 when you're starting counting at 0. Not too bad. And And then what are we going to do? We're going to do this. System out print dot. And are we going to print data? Or are we going to print next? We're going to print next. That's what I'm going to try doing. And then let's make this a little bit more aesthetic, shall we? Let's say the next number in the node is blank, because we can add strings to ints. And let's run it. So let's compile our code because we're good people. We're not bad people. Now we're going to run it. What do we think is going to happen? And I'll put this in the for loop as well so we can breakpoint it. Debugger. Go through. We're creating our first object, foo. It has data equal D. Print it out. We get 1. Next, append to tail. Now we're appending this number 2 to foo. Foo looks like this. Now D equals 2. This, which is self, go through. And now, what do we think this is going to be? Well, excuse me. It looks like this in our object. It's going to be foo, data, next. Next is data, next, null. And I equals 0. So let's see what it prints out. The next node is interesting. I don't know the answer to this. Okay, so I made a mistake. My fundamental understanding, there's something about my understanding about the code is wrong. That is okay. That is the point, right? That is why we're doing what we're doing. That's why I'm doing what I'm doing. I don't understand something. It's okay. The beautiful thing about coding is that you do not need to understand everything, okay? You can experiment. The reason I became, in my opinion, so in love with coding and have found some sort of success in it is that I could be wrong 1,000 times and all I need to do is try again and I could eventually get an answer and then people would be happy and they would pay me for it. I love to be paid for just trying shit out. What is the problem here? I don't know, so let's find out. I had to eat something, otherwise I was gonna, I don't know. Okay, so I said print foo.next, and it printed out whatever this nonsense is, some hash of the foo object. It is not showing me it is not printing out the object that I want, which is the data. I would have thought the data, I would have thought that .next would have done it. It seems to me I got it. I understand what's wrong. But do you know what's wrong? I will give you 5 seconds to, I'm going to go to the restroom quickly, come back in 2 minutes, and see if you have an answer. The answer is on screen. I'll be right back. Okay, there you go. All right, you got it? So the answer is next is a node type. So when I'm printing foo.next, I'm printing a node type right there. And so why would I expect an int to come out? I had a fundamental misunderstanding of what next was. Next is a node type. And so when you go node n.next, you're saying get me the next node, which makes a lot of sense. So let's put that node in there. Next is a node type. We are grabbing the next node object, not an int. Of course not. Makes all the sense of the world now that I understand it, of course. Which means since end is a node type, this would also make sense, right? End is a node type. So we say, since dot next is a node type and end is a node type, then this is kosher, right? Because otherwise, if this was an int and this was a node, then since we assigned n.next to be a node type, in Java that would complain. You're saying you're assigning an int to a node type. You can't do that. So the simple answer is we need the data. So if you run this again, I'm confident. Go through. We go through one at a time. These are our nodes right here. We say bam. The next number in the node is 1. The next number is 1. Now I'm not confident about that. Okay, we have another problem. I'm excited about this. We don't understand something, and that matters. Okay, I understand why the error occurred. It just came to me, but I don't know the fix yet. So the issue is foo. We haven't .nexted foo, right? So we need to traverse a linked list, which is actually, if you didn't know, a common interview problem. So we're actually entering a pretty good area to go into. I'm excited about this. All right. So traversing a linked list is not as easy as just saying, give me the next thing. So this is not going to work. I realize now why I shouldn't have done this. So we shouldn't add a method into here, some sort of action to take such that we can grab the last object from the node. I do not know the answer how to do this. We're going to find out how to do this by ourselves. Maybe with some hints if we can't figure anything out. That's okay. It doesn't matter. We're doing this for no one but ourselves here. So how would we grab the next data point from a node, from a linked list? Well, we should probably traverse the linked list, as I said. How do we do that? I don't know yet. We're gonna find out. Okay. Let's build on our node class here. We'll call this pop. So public void, maybe? No, it's gonna be an int. Pop. What's happening here? Stop. All right, that was weird. Okay. This is gonna be an int object, and we're gonna call it would it be void? Append to tail. No. Would it be public? I don't know how to do this. Int pop. I guess it's that. And we've got to do something here. And this is wrong because must return a result of type int. Ah, I see. So you're gonna like return. Let's call it int foo for now. Oh, we don't. Well, we've used that. How about fa? Return fa. And fa equals 1 for now, just so it doesn't error for us. All right, we're gonna change that, but that's we're gonna change, or we're gonna try to pop an int from a linked list. Okay, traversing a linked list and getting the output out. How are we gonna do that? Well, does this need any object entity? It does not. It simply needs self. So let's just do this as brute force as we can. I am not an expert here. I keep saying that so people don't feel like, how come he doesn't know? Whole point of the channel, or this part of the channel, we're learning here. So, do you have any guesses? I mean, I have one that kind of comes to mind. While, and we'll get rid of fa. I'm just putting that there so I don't see the red. It distracts me. While n.next does not equal null, let's call this print nodes. Print nodes. And actually, we can make this void too. We don't really care what the output is. We don't need an output. While n.next equals null, and n node n equals this because it's self. N, we'd say system. Do we have the line from down here? Let's take this right here and put it right here. Okay. And then let's call this n.data. Is it that simple? N.data next. We're not done yet. We're missing something very critical here. The answer is we have to traverse. Right now we're just saying, okay, if n.next is not null, then print the results. But how do we get to the next item? We have to move. So we have to say n equals n.next. Remember, n is a node type, and n.next is a node type. So we're just saying get to the next node type. We're just traversing through. So we do this, and we're good. If and you know, if we want to, we can just say this is the end of the list. Okay. Well, now let's try running it. So we'll say foo.print nodes. I'm excited. We can be willingly wrong here. So we know where we're at here. It goes through, prints them out, appends to tail, checks that. Good. The next number in the node is 1. Append to tail is 2. So we missed something. I see. I know the answer, but do you know the answer? I misread something. And that is this. If n dot equals null, then we're printing the last. Let's print the last one. We're not going to get access to the last one in our list if we didn't add this line, because you go through and you say n dot next is 2, but the one after 2 is null, so we're just going right here. You could also put this at the outside and just say do this, but I think that's a little less refined than saying if we do have next null, then n.data print it. So, actually, this is a little bit more interesting. I wonder if I can just do this. Here's why I'm doing this. Because even though my answer was technically true, it was adding a bunch of if statements, which is algorithmically, you're just saying check, 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 check. What if you have a very long list? Now you're having all these if statements being, and like, it's going to be fast to us, but it's not technically computationally efficient. I don't want to check all those times. If I know, well, that's going to happen no matter what. So, yeah, let's run this. Let's see what happens. Let's not be afraid. We don't live in fear, as a good man has said. We go through, print it, append to foo, print it. There we go. The next number in the node is 2. We're done. Okay. So we just built a node class. We iterated through it, and we even were able to traverse the linked list. Very interesting. We did it by ourselves. Very cool. All right. Well, I like to leave on a high note, and that feels like a good and productive time. I am going to call it there and go enjoy my day for a little bit. So, I mean, I'm enjoying this, but I will be back later today probably to stream. Roleplay, that is. Adios.